So what we want to do here is do the binomial expansion up to the x squared term on this fraction here. So we've got x plus 3 divided by these two polynomials. Now, what we can do is rewrite this in terms of algebra that make this binomial expansion a little bit easier. So let me show you what I mean. So equivalent to x plus 3 is in the numerator, so whatever happens I can times by that. And then what I can then do is do these to the power minus 1 each, multiplied by each other. So then I can write this like that for the first one and times it by 1 minus 3x to the minus 1 for the second one. Let's make that look a bit neater for the minus 1. Okay, now for binomial expansion, I know how to deal with this and I know how to deal with this, and I can just multiply by this. So that's kind of my building blocks. Now the binomial expansion formula looks like this. So 1 plus ax to the power of n. That is the equivalent to 1 plus n times ax. And then that's divided by 1 factorial. Just write these up in their sequence. Then the next term along, I've got n times n minus 1 times ax squared this time over 2 factorial. So that's kind of the pattern that it takes, and keep going on with that kind of pattern. Now all I've got to do now is separate this. 1 is at the front, so separate that, that's fine. The ax will just become minus x minus 3x. So I've got what my x's are and a's are, and then my n in both cases is going to be minus 1. So let's deal with the 1 minus x to the minus 1. So quite a famous expression this, but I'm going to show you how it's derived from this. So here, looking at this, what's my ax? Well, my ax is minus x, so use that. Then my n is minus 1. And all I've got to do now, just plug those numbers into there. So then this is equivalent to 1 plus n is minus 1. So I've got minus 1 times ax. Well, ax is just minus x. And then divide by 1. N and n minus 1. So minus 1 and then minus 2. So minus 1 minus 2. Ax is minus x squared. And then divide this by 2 factorial, which is just 2. So now simplifying this all together, this now becomes, just put this in a box to keep it separate, this now becomes 1 minus 1 times minus x is plus x. Here I've got minus 1 times minus 2 is 2. Divided by 2 cancels out. And minus x squared just becomes basically x squared. So that's my first one taken care of. Now let's deal with this one. So if I do this one, I've got 1 minus 3x to the minus 1. Basically n is minus 1 again, and this time my ax is minus 3x. So here I've got ax is minus 3x and n equals minus 1. So that's my building blocks, still using this formula. So then this one becomes, just put that in a box, going to keep that. Then this one becomes, basically just going to put a minus 3x in each of these. So if I do that, I've got 1 plus minus 1 minus 3x over 1 plus minus 1 minus 2 and minus 3x squared all over 2. Okay, so same thing, just where I see a minus x, I put minus 3x into there. That's what I've done. Just to make it a bit quicker. You can go through the steps a bit more carefully if you wish. So then I've got 1. Here I've got minus 1 times minus 3x over 1. That's going to give me positive 3x. And here I've got minus 1 times minus 2 over 2. They just cancel out as they did there. And I've got minus 3x, quantity squared. This gives me plus 9x squared. Okay, that's all good. Now what I can do is I can deal with these two terms together, and then I can multiply by x plus 3 at the end. So basically what I've got now, if I just write it all out here so you can see what I'm about to do, I've got x plus 3 Now I'm only going up to the x squared term, so I didn't need to go past anywhere here. So now 1 plus x squared, and then 1 plus 3x plus 9x squared. Basically all I've got to do now is just FOIL all of that out. So let's just take care of these two bits down here. So 1 plus x squared multiplied by 1 plus 3x plus 9x squared. Okay. Now let's deal with this one first and distribute it with all of these three. So then I've got 1 times all of that, so I'll just rewrite that. Now let's distribute the x. Let's get that one away. So multiply x by all of these. I'll have x and then 3x squared. And if I multiply this by x, I get 9x cubed. Well, I don't want it. Well, it's not necessary because I'm only going to x squared. So that's enough for that one. And then that's the x done. Now let's deal with the x squared. Now you'll notice, multiplying by these two, I go up to x cubed and x to the 4. I'm not interested. So it's just x squared times x. So it's plus x squared. So that's up to the x cubed term, up to the x squared term, sorry, on this one. So let's just simplify it off a little bit. So I've got 9x squared plus 3x squared plus x squared. That's going to give me 13x squared. So let's just write that here. So I've got 13x squared. That's my squared terms. Just underline them as I've done them. Then I've got 3x and x. That just gives me 4x. And then just the 1. Okay, so now I'm just going to FOIL that with the x plus 3. Okay, now expand it out. Well, the x with the 13x squared I don't need. So I'm just going to deal with these two. So then I've got x times 4x squared. And x times 1 is just plus x. Take that away. And now 3 times all of these terms. And I'm going to need more because it's up to the x squared term. So 3 times that, 39x squared, 12x, and then 3. Let's just squeeze that on there. Okay, right. Put all the terms together. So 39 and 4 is 43. And then I've got x plus 12x, which is 13x, and the 3. So that's the binomial expansion up to the x squared taken care of. Now, when is this series valid? Now, we know the binomial expansion in this is valid for absolute value of ax is less than 1. Okay. Now here we've got two different ones. This one's just a 1 in the numerator. We can disregard that for now. But these two, we're applying the binomial expansion to. This rule counts. So for this one, it's valid for ax, which is minus x. So minus x is less than 1. So then for that one, just basically absolute value of x is less than 1. So that's the same thing. This one here, a little bit different. We've got minus 3x. So again, use this. So now we've got minus 3x is less than 1. So the minus sign disappears inside the modulus. So I've got 3x is less than 1, which now gives me, divide both sides by 3. So then I've got x is less than 1/3. Okay, so I've got this one and this one. So what we do in this case, we take the one with the smallest range. So this one, modulus of x is less than 1. So this one is valid from minus 1 to plus 1. So somewhere on a number line there. And just mark them up. This one is valid for 1/3 and minus 1/3. So here we're at 1/3. That's my 0. And then minus 1/3. I'll just put that like that. So this is where our series is valid. So these bits here are not valid for this expansion. So that's where this series would be valid for. Okay, and then we are done.